Okay, let us see some more examples about our horizontal plane. So we start with this one. A pack of mass 200 kilograms pulled along a horizontal plane by a force of 400 newtons moves at a constant speed. Find the angle of friction and resultant force if 400 newtons is applied horizontally. Of course, when we say friction, it means they don't need to tell you that the plane is rough. So from there, in our solution, we start by putting a simple sketch. So first of all, we are going to be having our surface here. This is going to be our surface. We are having a part. This part is having 200 kilograms. Of course, it's going to be having the weight of 200, the mass times the gravity with a reaction. It's being pulled with a force of 400 newtons, but because it's going in that direction, we are going to have friction opposing in that direction there. Okay, because we have a constant speed, it means that acceleration is 0. So from there, our acceleration is going to be 0 because of that word constant speed. But the body is moving. So meaning from there, you can see that we are not going to have any motion upwards or in this direction. So meaning from there, our R is going to be equal to 200 D, which will be 200 times 9.8. And so our R from there is going to be 1960 newtons. After having that, remember they are asking for the angle, find the angle of friction and the resultant reaction. Okay, so we have this and we have, remember the resultant reaction is acting between the reaction, the normal reaction, and then the frictional force. So what is our frictional force? You know now, this one, remember that from here we don't have anything left, like the friction. So our resultant force equaling to MA. We are going to be having now the resultant. So let us consider going in this direction. Okay. Direction of motion is in this direction, like this. So we are going to be having 400, then minus the force which is opposing, equaling to mass, which is 200 times 0. So start from there. Our F is going to be 400 newtons. This is the basic of this question. Okay, now from there, we know that now we have our frictional force, so you can simply sketch it now. So I have this like this, and then I have my reaction there. Now the resultant is what is going to be in between these two things there. So this is going to be my resultant, or what we call the reaction, the maximum reaction, which we are calling T. This is our R equaling to 960 newtons. This is our frictional force, our F equaling to 400 newtons. Now it's saying the angle of friction is between the resultant and then the normal reaction. So from there, I think you can every get this one. So our T is going to be from this direction and then coming in this direction like that. So from there, so our T is going to be the square root of, now this square, 1960 square, then plus 400 squared. So our T is going to be so they are getting, so I'm getting, sorry, so my result 90 here is 2000.39. Okay, when I round off, it's going to be 0.4. So if I round off, I get 0.4. If I round off that figure, I get 0.4. So if I round off, resultant. Now to get our angle of friction, we say that from here, you can see that from there. My tan lambda is going to be the opposite, it is going to be this opposite, which would be 400 over that adjustment, which is 1960. You view this as this. Okay, this is how we can easily, if you want every seed, that is going to be the idea there. This is going to be lambda, then this is going to be 400 newtons, and this is going to be 1960 newtons. This is our T. So that's where from here you can generate that. That's why we have this. We use the Pythagoras, the square of this is equal to the square of this plus the square of this, then you get the square root. Then if you want tan lambda, it's going to be equal to the opposite over adjacent, as simple as that. So our time is going to be tan inverse of 40 over 196. So our lambda here is going to be it's 11.53 degrees. So this is the angle of friction. Okay, let us now turn to example 2. When our horizontal force of 13.7 newtons is applied on a body of mass 10 kilograms, resting on a rough horizontal plane, it moves with an acceleration of this. Find the coefficient of friction and the angle of friction. So in our solution here we have now acceleration. So we start by giving us a simple sketch. We have a body there. This body is having 10 kilogram mass. It has that, then we are going to be having a weight of 10 Then there is a reaction acting. So that when a force of 37, so we have 37 newtons. This side, we are going to be having now a frictional force because the plane is rough. So here, they are giving us acceleration as 1.25 meters per second squared. So the acceleration is going to be in that direction there. Because the force is pulling, we say the acceleration is in the same direction as the force. So from there, you can able see that our R is equal to 10 B, which will be 10 times 9.8. So our R is 98 newtons with ease. And then you see from here, you know that from our FR, the resultant force is equal to R is MA. So it's that now this body is going, our acceleration is in this direction. That's our acceleration in that direction. So meaning that now what is pulling it in that direction is 37, then minus the opposite, the frictional force. It will be equal to the mass of the particle, which is 10, times the acceleration 1.25. So from there we are having, remember, this is 37, then minus mu r equaling to, this would be 12.5. If I take this side and bring this side, I have 37 minus 1.25 equaling to our mean, which we are looking for, then 998 as our reaction. And so from there, you can able see that I have 98 mu equaling to 524.5. If I can divide that now, my mu is going to be 0.25. So if I have mu, now I can get the angle of friction. This is part A. Then my part B, the angle of friction is always given by, remember our tan alpha is equal to mu. So meaning that now mine is going to be tan inverse of lambda, of mu, which will be tan inverse of 0.25. And so my lambda will be 14.04 degrees. how we can get the angle of friction if we have mu, basically. Using this equation, because of that, tan of the angle of friction is equal to the coefficient of friction, as simple as that. So, that is the basic. Whenever you have friction, please go with the basic. Resultant force is equal to the mass and the acceleration. All these ones we are working with this. Resultant force is equal to the mass and the acceleration, as simple as that. But here the acceleration was 0 because of the constant speed. So those are the basics we are going to see now in the next lesson, when the force applied on the body is at an angle. See you there.